let's start section 8.3. In this section, we'll be able to graph linear equations and absolute value equations. In question 1, let's find the x and y intercepts so we can graph the line. To find the x-intercept, recall we must let y be equal to 0. And if I let y be equal to 0, the 3y would disappear and we have x is equal to 6. That gives me the x-intercept of 6, 0. This is our x-intercept. And to find the y-intercept, we do the opposite. We let x be equal to 0. And so if x is equal to 0, that cancels out, and that leaves us with 3y equals 6. I can solve for y. Let's divide both sides by 3 to get the y by itself. And so y is equal to 2, and that is the y-coordinate of our y-intercept. The x is 0, and the y is 2, so the y-intercept is the point 0, 2. Since we have both the x and y-intercept, we're able to graph our line. I will plot down the x-intercept first, 6, 0. 1, 2, 3, 4, 5, 6. This is 6, 0. And then we'll plot the point 0, 2. This is our y-intercept, 0, 2. Let's connect the 2 points. And this is our graph. Let's try it again for example 2. At any point, if you want to try these examples, please do so. Pause the video and try it on your own. In example 2, I am going to find the x-intercept. And remember, to find the x-intercept, you let y be equal to 0. Let y be equal to 0. And if this is equal to 0, that cancels out, leaving us with 5x equals -10. We could divide both sides by 5 to solve for x. X is equal to -2. That's our x-coordinate. This is our y-coordinate. The x-intercept is -2, 0. To find the y-intercept, you let x be equal to 0. And if x is equal to 0, this part of it cancels out, and leaving us with -2y is equal to -10. I can divide both sides by -2 to get the y by itself. Y is equal to +5. This is our x-coordinate, and this is our y-coordinate. So we have the ordered pair 0, 5 as our y-intercept. We can draw a graph now. We'll plot the point -2, 0 first. That's our x-intercept. And to graph the y-intercept, that's the point 0, 5. And we have the y-intercept charted down. We'll connect the 2 points. And this is a line graph for the equation 5x minus 2y equals -10. In question 3, we're going to use a different technique using the slope and y-intercept. Recall the slope-intercept form for a line is y equals mx plus b, where the m is the slope of the line and the b is going to tell us that the y-intercept is 0, b. To solve these questions, we have to get it into slope-intercept form first, and this is great. The equation is already in slope-intercept form. So the m is 2/3 and the b is -6. The slope is 2/3 and the y-intercept is the ordered pair 0, -6. And with these two pieces of information, we're able to graph the line. We'll start by plotting the y-intercept first. 0, -6. 1, 2, 3, 4, 5, 6. This is the point 0, -6. And then we'll use the rise over the run to plot our second point. We'll start from the y-intercept 0, -6 and go up 2 spaces, 1, 2, and then to the right 3, 1, 2, 3. So this is going to be our second point, and that's allowing us now to graph the line with 2 points. Again, from the y-intercept we go up 2, 1, 2, and then we're going to go to the right 3 spaces for the run, giving us our second point. In question 4, it's really cool that this thing is already in slope-intercept form, so I can write down the slope. That's -5/2. Whatever is in front of the x is going to be the 5/2 in this case, which is our slope. Our y-intercept is the point 0, 5. And now we can graph this line. We'll start by plotting the y-intercept first. 1, 2, 3, 4, 5. This is the point 0, 5. Then we'll use the rise and the run for the slope to find our second point. We'll start at the y-intercept 0, 5 and go down 5. 1, 2, 3, 4, 5. And to the right 2. 1, 2. This is our second point, and we'll connect the 2 points to finish our line. When we see an f of x, just think of it as the same as y equals -5x plus 8. These mean the same thing, it's just a different notation. The first one is function notation, and the second one is just linear notation. It means the same thing. The slope is -5, that's the number in front of the x. And for our y-intercept, we have the y-intercept is the point 0, 8. So we can plot this graph just like the others. We'll start with the y-intercept first. 1, 2, 3, 4, 5, 6, 7, 8. This is the point 0, 8. And the slope is -5, but remember, you can rewrite this as a -5/1. Then you can read the rise is -5 and the run is +1. From the y-intercept, we can go down 5. 1, 2, 3, 4, 5. And to the right 1 space. That's going to give us our second point. And we could roughly sketch this line. It's a good idea to buy some graph paper so you can sketch these graphs a little bit neater than what I have here. Question 6. It's time now to graph an absolute value equation. The first step is to let whatever's inside that absolute value be equal to 0. So let x minus 7 be equal to 0. And then I can solve this pretty easily. X is equal to 7 is my solution for when the inside is equal to 0. This is going to tell us the location of that vertex. That's a very important part of the absolute value graph, and that's why we set the inside of the absolute value equal to 0 first. Let's put that 7 in a table so we can plot some points. Now I like to put the 7 in the middle, then pick values below 7, which are 6 and 5, and some values above 7, let's say 8 and 9. These points are just around 7. It gives us a good idea of what the graph actually looks like. On the right, we'll put the function x minus 7, the absolute value of x minus 7, and then we'll evaluate it for each value. Let's start with a 5. We'll plug in a 5. 5 minus 7, that's negative 2. So we'll have to take the absolute value of negative 2, which gives me a positive 2. For the next one, we'll plug in a 6. The absolute value of 6 minus 7 is going to give us a absolute value of negative 1, which is positive 1. When we plug in a 7, 7 minus 7 gives us 0. The absolute value of 0 is just 0. We'll do it again for 8. 8 minus 7. The absolute value of 8 minus 7 is the same as the absolute value of 1, which is equal to 1. One more time, we'll use a 9 instead of an x. 9 minus 7 is 2. The absolute value of 2 gives us 2. Now you can see why we chose to let the inside be equal to 0, because it allows us to find the location of that vertex. So I'll start by plotting the points 5, 2. And if you want, you can make a table here that tells you x, y, what to plot. This is 5, 2. This is 6, 1. 7, 0. 8, 1. And finally 9, 2. So these points are from each of the x coordinates, and our function output is, of course, the y coordinate. So now we can plot the points 5, 2, and we should get a nice shape here. 6, 1, and 7, 0 is right here. That's our location of our vertex. 8, 1, and 9, 2. So you can see now the absolute value has a V shape to it. It has a V shape. If I plotted more points, you can see that this V does extend forever in either direction. And that's why we set the inside equal to 0. That's going to tell us this point here, and that point is known as the vertex for an absolute value graph. It's where the graph starts changing directions. Let's try it again for question 7. Always let that inside be equal to 0 first. Let's let x plus 1 be equal to 0, so we can solve for the vertex. And this gives me x equals negative 1. This is going to allow me to build a table now. We'll start with the table. Negative 1 is in the middle, and I'm going to pick values that are below negative 1, such as negative 2, negative 3, and values that are above 1, 0, and 1. In the middle here, we'll use the function, the absolute value of x plus 1 minus 6, and far to the right, we're going to write down our ordered pairs. Let's plug in a 3. The absolute value of negative 3 plus 1 minus 6. We'll have to do the inside first. The absolute value of negative 3 plus 1, well, that's the absolute value of negative 2 minus 6. Well, the absolute value of negative 2 is actually positive 2. Positive 2 minus 6 is equal to negative 4. So our first ordered pair is negative 3, negative 4. For the next one, we'll plug in a negative 2 and then simplify. Negative 2 plus 1 is negative 1, so we have the absolute value of negative 1 minus 6. The absolute value of negative 1 is a positive 1. 1 minus 6 gives me negative 5. We'll plug in a negative 1 now. 1 minus 1, that gives us a 0. The absolute value of 0 minus 6, that's minus 6. And so these 2 points are negative 2, negative 5, and negative 1 comma negative 6. Continuing the process, we'll plug in a 0 this time. 0 plus 1, that's 1. The absolute value of 1 minus 6 gives me a negative 5. So this point corresponds to 0 comma negative 5. For the last one, we substitute a 1 into the original function. 1 plus 1 is 2. The absolute value of 2 minus 6 is going to give us a negative 4. So this is the ordered pair 1 comma negative 4. Now we could plot the points negative 3 comma negative 4. That's the point negative 3 comma negative 4. We'll plot the point negative 2 comma negative 5. And this is the point negative 2 negative 5. Then negative 1 negative 6. 0 comma negative 5. And 1 comma negative 4. So we do have that V shape again, where the vertex is when that middle term is equal to 0. So we have the vertex here, and the graph does have that nice V shape that we expect from an absolute value graph. This is your opportunity now to take some time and to pause that video so you can do this problem on your own. I'm going to start by letting the x minus 2 be equal to 0 again. That's so we can find the location in that vertex. This gives me x is equal to positive 2. When you get that value, you make a table. Start with that 2 in the middle, and then pick some numbers that are smaller than 2, and pick some numbers that are bigger than 2. And then you could construct your table to find your values. We'll plug in a 0. 0 minus 2, that's negative 2. The absolute value of negative 2 is positive 2. So we have 2 minus 4, that gives me a negative 2. So our first ordered pair is 0 comma negative 2. For the second one, we'll plug in a 1. 1 minus 2 is negative 1. The absolute value of negative 1 is positive 1. So this is 1 minus 4, which is negative 3. Our second point, 1 comma negative 3. For the third one, 2 minus 2, that's going to give us a 0. The absolute value of 0 is 0. 0 minus 4, well, that's just a negative 4. Let's plug in a 3. 3 minus 2, in absolute value, minus 4. 3 minus 2 is a positive 1. The absolute value of positive 1 is 1. 1 minus 4 equals negative 3. For the last one, we'll substitute a 4. 4 minus 2 is 2. The absolute value of 2 is 2. 2 minus 4 equals negative 2. So we can see now we have a table with all of the ordered pairs we need to graph our absolute value function. 0 comma negative 2, 1 comma negative 3, 2 comma negative 4, and this is going to be the location of our vertex. 3 comma negative 3 is next, then 4 comma negative 2, and we do have that V shape that we were looking for. In question 9, it's a little bit different. Notice there's a negative in front of the absolute value. What is that negative going to do with our absolute value graph? Let's find out. First, we let the inside again be equal to 0. So let's let x minus 3 be equal to 0 to find that location of that vertex. And that means x is equal to 3. When we solve that equation, x is equal to 3, which allows me to make a table. 3 is in the center. We'll pick some values below 3, which is 2 and 1. Above 3, let's say 4 and 5. Okay, now we can do some substitutions. We'll plug in a 1. 1 minus 3 in the absolute value, then subtract 4 from it. 1 minus 3, that's negative 2. We have the absolute value of negative 2, which is positive 2. But there is a negative in front of that, which actually makes it a negative 2 again. So this is negative 2 minus 4, which gives me negative 6. So the first ordered pair is 1 comma negative 6. Again, be careful. You got to do the inside of the absolute value first. And the absolute value made it a positive, but the negative changes it back to a negative. For the second one, we're going to substitute a 2. 2 minus 3, that's negative 1. The absolute value of negative 1 is positive 1. But, hey, again, there's a negative in the front. So it's negative 1 now, minus 4. So take your time, do it in pieces. Do the inside, then the absolute value, then account for that negative. So this is a negative 5. 3 minus 3, that's 0. The absolute value of 0 is 0. With the negative in front, that's still 0. We have 0 minus 4, which is negative 4. And we can finish off this table. 4 minus 3 minus 4. So 4 minus 3, that's positive 1. The absolute value of positive 1 is 1. With the negative in the front, that's negative 1 minus 4, which gives me a negative 5. For the last one, we substitute in a 5. 5 minus 3 is 2. The absolute value of 2 is positive 2. And so this becomes negative 2 minus 4, or just negative 6. We'll start by plotting the point 1 comma negative 6. Then the point 2 comma negative 5. Then the point 3 comma negative 4. And you can see now this is a V as well, but it's facing upside down. We'll plot the last point 5 comma negative 6. And this is a V graph, but it faces upside down. And the reason for that is that negative in the front. That negative in the front causes that V graph to be facing down. So remember, if the coefficient in front of the absolute value is negative, it's going to flip our graph upside down. Question 10, we're going to have to graph, find the intercepts, and state the domain and range. That's a lot of things to do, so let's start by letting x minus 7 equal to 0. To solve for x, we add 7 to both sides. We get x equals 7. This is going to tell me the location of my vertex. So we'll have the 7 in the middle. And we'll write down our function just like we always do. And we'll create a table here. Let's pick values 6, 5, 8, and 9. Again, you can pick as many points as you want. I just want to get a general feel for the graph, so I like to pick 5 points. We'll substitute a 5 into the equation. 5 minus 2 is negative 2. The absolute value of negative 2 plus 2, well, negative 2 in absolute value becomes a positive 2. 2 plus 2 is 4. This is the point 5 comma 4. Using a 6 now, 6 minus 7 is -1. The absolute value of -1 is actually a positive 1. So we have 1 plus 2 gives us 3. When we plug in a 7, this eliminates 7 minus 7, which is 0. 0 plus 2 gives us 2. This is our vertex, 7, 2. 8 minus 7 is equal to 1. The absolute value of 1 plus 2, that's equal to 3. This gives us the point 8, 3. For the last one, let's substitute a 9. 9 minus 7 is 2. The absolute value of 2 is 2. Plus the 2 gives us 4. And this is the point 9, 4. So we have the location of the vertex. That's where our V is going to start. So it's actually a good idea to start by graphing the vertex first, and you'll see the points form a V shape. But we want to also state the intercept. So we need to find the X and Y intercepts. And to do that, you can graph more points, or you can see the general pattern and figure out where it crosses the X and Y axis. So let's do that now. I'm going to go to Desmos.com, and this is going to allow me to graph this function for you of x minus 7 plus 2, and you can see right there, this is a nice graph. It allows me to quickly check my work. We know the vertex is 7, 2, so I can physically type in the entire equation, or if I want to, I can write ordered pairs 7, 2, and I can label it. So we have that point. We can add some more points here. So Desmos is a really good resource. It's a free graphing calculator for us. I can add 8, 3. Label that as well. And so we can add some more points, 9, 4. So those are all of those points that we worked so hard to get, and it does lie on our absolute value graph. Now, what is the y-intercept? Well, you can see here the y-intercept is the point 0, 9. So we can continue our pattern and see that it does cross the y-axis at 0, 9. But if you zoom out, there is no x-intercept. There is no x-intercept. So I can answer some questions here. The y-intercept is 0, 9, and we got that from Desmos. We got that from Desmos by looking at the graph. And there is no x-intercept. So the x-intercept, I'm just going to write there is none. But wait, we have to find the domain and the range. Remember, the domain is the set of x values and the range is the set of y values. So let's go to the graph. If you look, the graph goes forever to the left and forever towards the right. So the domain is -infinity to infinity. And for the range, we're looking for the y values. Looking at the graph again, the lowest y value that we can have is that 7, 2. At that point, 7, 2, the y coordinate is 2. So the smallest value that we can have for y is 2, but it could go up forever. That's our range. The range goes down to 2. It's including 2, so I'm going to use a square bracket. And goes up forever, so we'll use the infinity symbol. This is our range. It goes left forever, to the right forever. For the domain, for our range, it goes down to 2 and up to infinity.